Hey, I'm Sophia.
And I'm Sanjana.
And we're the SS Science.
Get ready to sail with us
through a sea of scientific knowledge.
Okay guys, so today we're going to learn about chemical reactions. More specifically, combustion, which is a type of reaction and more commonly known as burning. So what you're going to need for this experiment is matches, a safe place to put the matches once you're through with them, a hair tie if you have long hair, and a candle. Now, different candles, this experiment works best with different types of candles. We found that a Yankee candle works just fine for this experiment. Alright, so the first step is you just want to light your candle. So now you just want to wait a little bit so that there's a bit of a pool of wax underneath the wick. Here's another cool experiment that we're going to show you.
I'm sure there is. So this is a really cool reaction that we watched, but can you explain to me exactly what a chemical reaction is?
Well, simply put, a chemical reaction is when you have one substance that turns into another substance. Or in fancier terms, your reactants turn into products.
I see. So how is what we did, which is a combustion reaction, different from a chemical reaction?
Well, a combustion reaction is actually a type of chemical reaction. Combustion is actually a type of exothermic reaction, and an exothermic reaction just describes any reaction that releases heat. So combustion reactions also typically have oxygen as a reactant and carbon dioxide, water, and heat as products. The presence of fire is also a strong indicator that a combustion reaction is happening.
Okay, I understand, but why did the candle go out when we put the lid on top of it?
Well, without all of the reactants, the reaction can't happen. Simply put, oxygen is a reactant. So when the fire burns away all the oxygen in our closed-off lid, and there's no oxygen left, the reaction, the fire, can't occur. It can't continue happening.
Okay, so if a combustion reaction is a type of chemical reaction, what makes it different from other chemical reactions?
Well, let's use our flame as an example. The reactants, our original substances, are oxygen and wax, and the products, our final substances, are heat, light, and carbon dioxide, which is the smoke, and steam.
Got it. So how exactly did we relight the candle using smoke?
Well, in this case, when we lit the candle, some of the wax managed to vaporize, which simply means that it turned from a solid into a gas. This wax vapor was carried up by the smoke, so when we held the relit match in the smoke, this wax vapor lit on fire, traveled all the way back down to the wick, and relit the candle.
I see, so that must mean that the wax vapor is a product of the combustion reaction, right?
No, it's actually not.
What?
The wax vapor is actually just some wax that got lucky and avoided being consumed by the flame.
Oh.
It's not actually a product because it remains unchanged throughout the entire reaction. It did turn from wax solid into wax gas, but it remained wax. It didn't turn into heat, light, smoke, or water.
Wow, that makes a lot of sense.
I'm glad it makes sense, and I hope it makes sense to you too.
Thank you for voyaging with us on the SS Science.
We hope you had fun learning.